Lordy, lordy, lordy. Guys, here I was thinking that we were all good on the hydronium pH stuff, and then I was looking through the homework from last night, and whew, not a lot of people were getting it, which worries me, because that means that either you guys weren't listening or I wasn't teaching. One of those two things happened, and I'm not going to say one of them is more right than the other. Could have been a combination of both. So let's go through this together, please, because you guys need to understand this. It says, what is the pH of an aqueous solution, blah, 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 blah. What is it looking for? The pH. Now in our notes, which I should have right here, I believe. Um, Here, there. In our notes, if you're looking for pH, this is what we're using. pH equals negative logarithm of H3O plus. Okay. What is the pH of an aqueous solution of 0.82 grams of hydrofluoric acid dissolved in 350 milliliters of water? So what that's asking us to do is to plug in our H3O plus concentration and then to solve it in the calculator with the negative log. But the problem is, do we have a concentration listed here? The concentration is supposed to be in capital M. We don't have concentration. So basing this off the problem we did in class, which was, I believe, which one did we do? This one. This was based on 16-3. We don't have M yet, so we're going to have to plug in our numbers into the moles over liters problem. Do we have moles? No. Do we have liters? Yes. So I'm going to plug in my liters in the bottom. And I don't have moles, but I do have grams. I'll put that in the top. And I'm going to have to convert. How do I get from milliliters to liters? We've done that a million times. How do I get from grams to moles? I have to divide by the molar mass, which for HF is 20.01. So I'm going to do this on camera so you can see what I'm doing. Oh, can you read that? I got to turn the brightness up. There we go. So I'm going to do 0.82 times 1,000. And then I'm going to divide that by 350. And then I'm going to divide that by 20.02. I'm sorry, 20.01. And I get 0.117. And that's capital M. So now that I have 0.117 capital M, that is my H3O concentration. So if I plug this number into this problem, pH equals negative log of that number, 0.117, this should give me my pH. So this is how I'm typing it into the calculator. I'm saying the logarithm of 0.117, I get negative 0.932. Let's say negative 0.932. So pH equals negative 0.932. Negative 0.932. Now what happens to these two negatives? They cancel out, so my pH equals 0.932. A super small pH. Okay. Hopefully that makes your instructions very more clear. If you didn't get this way, please redo this problem, or you're going to be doomed for today's lesson. The hydronium ion concentration in a shampoo is 2.0 times 10 to the negative fifth molar. What is the pH? So we're looking for the pH, so we use the same equation. pH equals negative log of the hydronium ion. So do I have my hydronium concentration? Hey, the concentration is this. Yes, I do. So I just plug that number in. pH equals negative log of that number. Fantastic. So now I'm going to go to my calculator. How do I do this so you can see it? There we go. And I'm going to do the logarithm of, and then I'm going to do another parentheses, 2 times 10 raised to the negative fifth, then parentheses, 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 parentheses. That gives me negative 4.70, let's say. Negative 4.70. So that's pH equals negative 4.70. Notice how I didn't type this negative into the calculator. I don't think you should either. What happens to these two negatives? They cancel out, so my pH ends up equaling positive 4.70. Hopefully this clarifies a little bit more of what you're supposed to do. I wasn't planning on doing the book problem on here, but I will. 424. Number 1. Okay, so number 1 said, find the pH. So I'm already going to be doing this. Some of you guys forgot to do this problem, period, even though it was written. pH equals negative log of the hydronium ion. Find the pH of a solution whose H3O concentration equals, it tells me what H3O is, 9.5 times 10 to the negative 8. So I just got to plug that number in there. pH equals negative log of that. Now I'm going to type that into the calculator. Oh, there we go, that'll do. So I'm going to do log. Again, I'm not doing that negative yet. I can deal with that later. Log of 9.5 times 10 to the negative 8th. And I get negative 7.02. Those negatives cancel out, and my pH is 7.02. Check in the book. Yes, that's correct. Okay. Hopefully this gives you more of an idea as to the system and the pacing of what you're supposed to do there. 8 minutes, not bad. Good luck. You're doing more of the same stuff today with POH. Not much is changing.